Let me introduce you to the technique of separation of iterated integrals. This is extremely useful. You will use it very often. But you have to be careful as to when I can use it and when I cannot. Okay, so first let me start with an example. So let's say I want to calculate this double integral here. Okay, so I first write it as an iterated integral, so it's an integral inside of an integral. And now take a look at the logic I can use. So this integral, let's forget about everything outside. So we want to calculate this integral. So from the point of view of this integral, I'm changing x, and therefore y is a constant, right? So we can take y outside of the integral, right? Like we did with normal one-dimensional integrals. Any constants can be moved outside, as long as they are multiplying everything. Which means that I can write this as y times the integral of between minus 1 and 1 of x squared dx, and now dy here. Okay, so this, what I did is completely valid, because y was multiplying the entire integrand, so I took it outside. So I took it here outside. Okay, but now notice how good this is, because now from the point of view of the outer integral, which is an integral along y, this no longer has y inside it, right? Because there are no y's here. So this will be just a number, because x will be removed when we substitute x equals minus 1 and x equals 1. So this will be just a constant, which means that we can move this constant outside of the outer integral. And therefore, I can write it as the integral of x squared dx times the integral of y dy. Wow! So this basically means that a double integral, which normally I have to calculate as an integral inside of an integral, I can actually also calculate it as an integral multiplied by another integral, which is even easier, right? Why could we do this? Well, we could do this because the integrand was the product of a function of x times a function of y. Okay? We cannot always do this. So let me write explicitly when we can do this and when we can't. So in general, if you have an integral between a and b and between c and d of f of x times g of y dx dy, okay, so you can first take g of y, which is a function that depends only on y, it doesn't depend on x. You can take it outside of the first integral, so this is equal to the integral between c and d of gy times the integral between a and b of f of x dx, and then dy. And now, since f of x is a function that depends only on x, this integral will be a constant. It won't have any y's. So this constant can be taken outside of the outer integral. So this can be written as the integral from a to b of f of x dx times the integral from c to d of g of y dy. Okay, so that is the separation of double integrals. So we started with a double integral and we end up with a product of two simple integrals. And this can only happen when the integrand, so this is the integrand, what we usually call f of xy. So the integrand can be written as a product of a function of x times a product of a function of y. Let me write you some examples. Examples where fxy equals f of x times g of y. So an example could be the one we did here, x squared times y. So that is a function of x multiplied times a function of y. Another example could be x squared times y plus e to the y. So this is still a function of x multiplied times a function of y. Okay. Now examples. Let's see some examples where this is not true. And therefore we cannot do separation of integrals. So some examples where this is not true, that's very easy. For example, x to the power y. We cannot separate that as a function of x times a function of y. Another example would be the cosine of x plus y. Okay, we cannot separate that into two. Now, some things might be tricky. For example, e to the x plus y. Can this be written as a function of x times a function of y? Well, if you do some algebra, you can write this as e to the x times e to the y, which is a function of x times a function of y. And therefore, this case should be listed here in the examples. Okay. So sometimes you can factor things so that it separates into a function of x times a function of y, and therefore you can apply this separation of iterated integrals, which makes the calculation now very easy, okay, because there is no integral inside of an integral. If you cannot separate the function into a function of x times a function of y, oops, sorry, this should be y, of course. If you cannot do this, then how do you calculate the integrals? Then you just do the iterated integrals as we were doing in the previous examples. So it's one integral first and the other integral outside, okay? So thanks for watching. So we will do this separation very often because it simplifies things in many cases.